Today is gonna be slightly different from usual because some of my technology here doesn't properly work. Software isn't always so reliable, and so we'll have to focus entirely on code today, which might or might not be up your alley personally. For me, that's a bit unfortunate because I was counting on it to draw some things out, to make some sketches, but we'll have to make do with what we have here. So, in the end of the last stream, we had a brief glimpse at outputting data to the output, to your console output if this was a desktop program, and right now in the output here in the browser tool by using the command writeLine, which is part of the console class, we get from the namespace system. We're able to just output stuff here. And it would show up in the output. And we also had a brief glimpse at how C# can handle different data types and strings combined. So, and I equals 10. Well, I can just use the plus sign and add the I to our string, which now does not mean we're adding two values. We're combining two values though. We're taking the string on the left, then we're taking the integer on the right, convert that to an integer as well, so we have a string on the left and a string on the right, and then we just push them together, make a string concatenation. So it's still kind of an addition, just a different form. Just still combining two things. I mentioned that this is similar to how we had conversions earlier, way earlier in our lesson plan, where, for example, a double could be filled with an integer just fine, because a double can store any number that an integer can. But if we were to store the double in an integer, that would be an issue, because technically a double can contain more data than an integer. And well, in this case, it would work just fine. We won't lose any data. In general, the computer doesn't know for sure which values will be in there. I mean, yes, looking at the program, it could figure out that this will be a 10 and it's fine, but that's not what the language is about. And so we have to force it to convert it into an integer and accept that it might lose information. For example, if the number we store in the double is too large, we won't be able to fit it inside a single integer, and we just tell it to drop the rest of the data, and it's fine if we lose information here. We just want it to be stored in integer anyway. We accept responsibility for it. We determined that this value, 10, is going to be fine to use, and just do it. So run this again. Code still works. If I didn't add this conversion here, this casting, we will get an issue because we can't just put a double into an integer as is. Now, something interesting here, an explicit conversion exists, which is just the compiler telling us that, hey, you probably meant to cast this into an integer, right? Which, yeah, we did. But that implies that there are cases where no such conversions exist. And one of them would be with a string. For example, let's try that a different way. Let's just remove this as well. We have a string as 1, 2, 3, like that. That's a simple string with a number in there. Of course, you know, since last time, that a string is actually just an array of character types. So what we actually have is a char array. Let's do it the old-fashioned way. We're still not at the shortcuts yet. We're gonna do that at some time. That. Let's copy that. So our string 123, 123 is just an array of the numbers 1, 2, and 3. You also know that these aren't actually the values 1, 2, and 3, those are characters which have a corresponding actual integer value in Unicode. And so neither these values, and especially not this array as a whole, can be directly put into an integer. So conversion from the string to an integer doesn't work. Even if we were to put it in cast like this, it cannot be done. On the other hand, this. What do you think this will do? Let's put this away for now. We can convert the integer, we can convert the string directly in integer. Can we do it this way? I mean, we did manage to combine strings and integer before. What do you think? Well, solution, it can't be done. Because casts are very useful and we will use them outside of simple types as we've known them so far, but usually they're reserved for we have one type of number and convert that into a different type of number or different format for the same number. But in both cases, the data isn't radically different from before, just slight differences. Like maybe the simplest case, we have a byte and store that into an integer, which is exactly the same format with just more space. And we can also go then backwards, storing an integer into a byte, which might lose information because we have less space, but at least the format is exactly the same. And in the language we have some leeway, because the compiler lets us do conversions between floating point and integer types, which are very different formats, technically, but it's still easy enough to handle and it's common enough, so we can get away with it. But strings and integers, very different things. They have very different meanings, are structured very differently, so there's no intrinsic conversion between the two. Not a simple one that we could call a cast. What we can do is use a special method. And there's actually a method that is part of a class called int.32 for integer with 32 bits. This class is actually one you've been using all the time because this and this means basically the same. Int is only just a different form of saying int32, 32-bit integer. Lots of things like int64, integer with 64 bits, which is long. Right, so int32 is a class which we can access just like we did with console. It's part of the basic set of classes we get with the language, specification, not directly, but with the framework we're working in. And so what we can do is use int and the dot operator, something you might not have thought possible, and we can access methods for this class. Again, might look more intuitive if I write it like this, uppercase. This looks like a class. This means the same though, int dot. And there are some interesting stuff, some interesting methods and even some values in here, some constant values, which we're not gonna talk about now. But besides these static methods that we could access that way, every integer also has some instance-based methods, non-static methods, which we can call by just using a dot on an integer, like so. Might look weird considering that all we've known int for is this is a very basic data type, a value type that stores a value. but we've seen value types before. We've made some ourselves using struct. So you know that a value type, even though it can be very simple, even though it's just a single memory entry on the stack, it can have methods and properties even, and fields and a lot of other stuff. And so int has one magic method, which is called ToString. And that's not actually limited to int. In C#, there are a few methods that are available for every single data type. Even if you don't write one yourself, the computer or the compiler will add it for you. The structs and classes we've made so far, they all automatically had a method ToString. We didn't write them ourselves, so the computer would just come up with its own implementation of it. Which isn't all that useful, but it exists. You could call it. But because it's not very useful, and because we've never talked about strings before, we never used it so far. But just as all types have it, so must int of course have it as well. And this method does exactly what it sounds like. It takes the value and converts that to a string, which can look any way you want. There's no requirement for the string that you put out to be a certain format, to look a certain way, or to contain any useful information. You could do anything. If you write your own type, you can write your own ToString method, and you can decide whatever you want to put in there. Up to you entirely. For integer, it is already predefined. We didn't have to write that method, and in there it's just straight conversion for this value into a string representation by having a string with a 1 and a 0. Actually, let's put this back in. It's a right line. Maybe it's useful after all. So if I do this, it will compile. Ah, forgot. Yeah, actually, let's use the using. We also learned about last time, and where we added. Bad. So a 10, the integer 10, can't be cast into a string, but we can call a method on it, a method that every single data type has, any value type, any class, be it pre-existing types or some that we define ourselves, they all have a ToString method that will give us a string that somehow represents that value. And for integer, it's just the string representation of a 10. Surprise. Now, how do we go about reversing this? For casts, we had the implicit casts, which would be done automatically, which we didn't have to worry about. And if we did need the reverse, even if it loses information, even if it's not that reliable, we could still force it with an explicit cast by putting the data type in brackets before the value. And with strings, conversion to strings and from strings is very common. We have the ToString method, which generates a string, which basically works for every type, always. That would be the equivalent of an implicit cast. And the reverse is what we call parsing. We would parse a string into whatever data we want from it, which could also work any way we want. For example, this string here, 1, 0. I mean, yes, I read it as a 10 right now, but this could also be just a 1 and a 0. Maybe this is binary. In that case, this would be the value 2. Or maybe it's trinary, and this is actually 3. Or maybe it's not 1, 0 as a single number, but two numbers, a number 1 and a number 0. So maybe it refers to an array. Like, those are all valid ways you could interpret this string. So parsing is not... I'm trying to put this down properly. It's not fixed. Let's put it that way. It's not fixed how you parse something. You can come up with different ways to interpret a string to generate your data. And there are legitimate reasons why you might choose a different way of parsing the data. As that the earliest example, is this a base 10 or base 2 number, if we convert this into an integer. Now to parse, you could come up with your own method, which is going to be your homework, by the way, so pay attention maybe a bit. But there's already a huge array of pre-existing methods for parsing strings into many different types. And of course, int has proper methods for parsing, one of which at least is called just parse. This is a static method in the class int32, or int, which we can also write, and it lets us parse any string into an integer. This method will accept a single string, like s, and it will return an integer. Like so. So what we have here is we start with integer 10, then we use the ToString method to convert our integer value, our number, into a string, a sequence of characters, an array. And then we take this character array, the sequence of Unicode characters, and put that into the parse method, which internally will then try to generate an integer value that matches that description, so to speak, which is what we are now outputting in the end. Of course, that's still a 10. So let's go a bit higher, 100, 1000, all the same. I mean, it's a bit a roundabout way of outputting this value in the console, but this would be the way to convert to a string and back from a string. Well, let's skip this part for now. Let's focus on a slight issue we might have at some point. Let's say I'm writing not 10, but O. Not a 0, but the letter O. What do you think happens if I'm trying to parse this text? 1 O. Yeah, only one way to find out. We get an issue. And this is something we haven't talked about so far. What we have here is an exception. The output isn't ideal because we're using the browser version, so best if you ignore this part down here for now. Let's focus on this stuff up here. Let me put it in the big one. This is, well, not the exception itself. This is what we would get if we run the ToString method on an exception. Exception itself is a class. Actually, there are many different classes. This one is not called exception, but format exception, which is a more specific type of exception. But exceptions are a way for the computer to deal with unexpected situations. If the compiler didn't catch it before, the computer might run into a case where it doesn't know how to process further. It has no instructions on how to handle a certain set of data. Doesn't know what to do, and in that case it will throw an exception. That's the terminology, it's throwing. And one of these exceptions now, the format exception, is an exception that is thrown in cases where the format of something doesn't match what was expected. So for the parse method, we expected a string that's the direct representation of an integer number. Of a number that can fit into a 32-bit integer. But it did not fit that. It's a single numeral and a letter. So it doesn't know how to parse that. So it's throwing the exception. And the output we get here contains some useful information. Less useful in our case, but still useful. This is the standard output. There's more detailed versions you can display, but usually that's if you decide to generate the string yourself instead of relying on the pre-existing ToString method. But this is still good. This is still useful. Let's have a quick look at how to read this. The first line tells us what type of exception happened and a message giving us a bit more detail. Some exceptions actually include data, which might be displayed in here or might be accessible through internal properties of that exception. Again, it's a class. You get an instance of that class that you might decide to pick apart. We'll have a look at that in a few minutes. Then in the standard format, after telling what type of exception happened and displaying the message that was output with it, which is intended as a message for a developer to read or for a user, you're then presented with a stack trace. Remember the term stack. Whenever we called a method, we would go on the stack. And this is where I wanted to make some drawings, but we started our program in the main method. And when we call a method in here, like parse, we would call the parse method, and that would be added on the stack. We would just put the necessary variables, the necessary data we have to use for the method parse. We would reserve that space below the space for the main method. And then when in parse we would call another method, we would reserve some additional space below that and use that for the next one. And then when that one calls another method, we would need to reserve more space. And that's the stack. It's always very linear. As soon as the method ends, we just jump back to the previous method, and just jump back to the previous method. And then maybe go back up or down the stack, depending on what we're doing. Are we jumping back from a method? Or do we call a new method and extend the stack? It means we always have a very linear order of method calls, starting at your entry point, the main method, and going down as many methods as have been called. And that you can see here, just in the reverse order. Our entry point is at the very bottom here, the very first method that was called. And from the main method, we called the parse method in int.32, right here. And internally in parse, we can see there's another method called parse int32 in a different class. And that class then called another method, throw, overflow, or format exception. And this is the last method on the stack. This is where the exception was thrown. And based on the name, you can maybe figure it out, but this is a helper method to make it easier for the programmers who wrote this code, the parse method, to handle exceptions. Just call this one method and it will handle generating the proper method and maybe add some data from whatever happened. So the actual exception happened in here for us, but that's not really necessary because we've called the parse method and we already know it's in a bad format, something we've known all along already. Some other things you can see in the standard output for exceptions. We have, after the exact location of the method call, well, basically after seeing the list of methods that were called, we can see this weird construct in some odd number followed by a colon and a 0. That's something you can not see properly here because we're running this in a browser. But usually, at least if you don't override it somehow, you would get a file name in here. So for example, the one down here, program.main, this would actually be program.cs, the file that our source code was written in, the file that was given to the compiler to generate the code. And this :0, this would refer to the line in our code where it was thrown, the exception. So for us, that would be line 7. So what we expected down here, CS, like that. At least that's the case if we include debug data, debug symbols. Otherwise, this value might be off. And this value can be overwritten. And actually there are commands to, or instructions to overwrite this as well, but specifics. In general, if you look at the output of a stack trace in dev environment on your local PC, you will see proper file names in here and roughly the right line number. If you're debugging, if you're just developing yourself, you probably have very accurate line numbers. And if those aren't helpful, you can still figure out where it happened by just looking at the main method and then looking at where do we call the method parse for integer 32. Well, that happens only once, so we know it's happening in here. Basically, we have the stack trace, which tells us where the exception was thrown, which part of our code happened or didn't happen. And what happened is up here. Something else is in the output. It says unhandled exception. See, when I would write this code and compile that into an executable for my PC and run it, the process would crash. Because I have an exception, but did not deal with it. I did not give any instructions what to do if this string is not a valid number, so I had an exception. And then I further didn't add any code to tell my program what to do when it encounters an exception. And so we have an unhandled exception, which will cause your process to just end. Like your operating system will just decide, I can't trust you anymore, I will just stop, because you can't proceed anyway. You don't know what to do anymore. Part of your program didn't know what to do, and there was no fallback code to tell the computer to just try something different, or try again. So your program ends. Therefore, what we need now is exception handling. Let's maybe make a simple example for exception first. Public static. Now let's make this private. Just for the sake of having a bit more variety here. Static. Actually, let's make this int. Int. Let's do this one. Looks like that. If input greater 0, return 1. That's if input less than 0, return -1. And now comes the magic word throw. This is the keyword we use when we ourselves create an exception, which is what I'm trying to do right now. So you can see that side as well. My program or my method receives one input integer, and if it's greater than 0, I want it to just return a 1, and if it's less, I want it to return a -1. But if it's exactly 0, I want it to throw an exception. Just a very generic one for now. Just to let us know that I received a 0 and I did not have any code that dealt with that situation. Not a very smart example, like you wouldn't write this code as is, probably, hopefully. But this is what it can do. And think of the throw keyword similar to a return. Return means we completely abort any further execution in this method. We immediately jump back in the stack to whoever called us. All the rest of the code gets ignored. If I return up here, nothing else matters. This code down here is ignored completely. Same here. All the code is ignored. Same with throw. Once I call throw, everything is ignored. But where return simply returns the value as intended, we expect an integer to be returned when we call this method. A throw will cause an exception, which is like a separate branch of returning values. That's always running in parallel to what you write up here as return values. It's like exceptions can always be returned from a method, so to speak. Every method can automatically return an exception. It can throw an exception. No matter if it's actually returning a value or a void, if it has any ref or out parameters, can always return an exception. And an exception is just a class exception that we can write like so, for example. And we can also give it some arguments, one of which is a message, like what was 0. Not very helpful message, but we can do that. So let's try sign 1. Let's try to execute this code. That returns a 1. A 10 returns a 1. A -10 returns a -1. But now if I try to run it on a 0, we get our exception. We created a new exceptions down here. We could also just do it like this. And then return E. It's exactly the same. Could do this. And now you can see again we have this output. Stack trace, we went first into the main method, and that called the sign method, and that's where the exception occurred. That's where the exception was thrown. It was an exception, just generic exception. And this is our message. Again, we see it twice here because we're running this in a browser tool, so the output is a bit different. We have an unhandled exception, therefore it has to be displayed in a specific way. Now let's say I want to deal with that. I might not be able to give the code direct resolution for the case where this is 0, but I can tell it a default behavior if any type of exception happened. I want to just give the program some instructions for if anything goes wrong, do this instead. And that's another construct that starts with a try. The keyword try. And try just means, hey, here's some code in a code block that you're gonna try and run. And if this does not work for some reason, if at some point you get an exception while running this code, do the following things, or one of the following things. And there are generally two ways you do this. You have either a catch, which is just, hey, catch the exception that was thrown somewhere in the method space down here. Well, see the terminology? We try to run some code. If this code throws an exception, we catch that exception. We prevent it from going further up. Right, line. So if I do it like this, I forgot the semicolon. Okay, let's try again. Like that. We had the exception here in our sign method, and we called that and decided, okay, just write out the name, or just write out the word exception in the console output and continue with your code, which, well, there's no more code, so just end your program after that. We didn't exactly deal with this value being a 0, but we still made sure the program ran to completion safely without breaking anything. For a simple program like this, doesn't really matter. But if we work on something large, you might need to do some finishing steps, maybe to save some work or to make sure to reset some data you've changed while running. Maybe you need to free some resources. Maybe you've had exclusive access to the monitor and you need to tell the system, hey, you can have the monitor back, I don't need it anymore. Or the printer. And that's what we have the catch for. It's just a way to deal with a situation inside the try that the computer did not anticipate. Or better, the programmer did not anticipate. So the computer didn't have any instructions for it. Of course, just having exception as an output is not helping us as the developer because, well, cool, my program ran to the end, and I know that something happened, but that's it. What happened? How can I fix this? How can I prevent this from happening again? So usually, you want to figure out what exception that was. And so with a catch, you can add brackets and declare an exception variable. Basically like this. You can imagine it a bit like having an out inside any method in here that's filled with an exception if an exception happens. Maybe that helps. But we have a catch and we declare a variable, an exception variable. And then we can do like this. And we can call the ToString method that generates the standard output you've seen the whole time. But since we're using the plus operator, using string concatenation, the compiler will know that we will call ToString on this automatically. It's the only way it can handle this. It's like an implicit casting. It's just doing it on its own. If I write ToString or not, doesn't matter. This ToString is something the compiler will add on its own, so I'm leaving that out. So if I run this now, I still have my own original text, exception. Just some information for me, hey, an exception happened. And the details are here. This is our original exception that was thrown. So if I see that as a developer, I know that something happened. I know my code dealt with it safely. And I can look up now where the original exception came from and create a fix for my program. Or maybe additional code just to narrow it down if this wasn't helpful enough. That also happens sometimes, where your systems do log that there was an issue, but not detailed enough. Happens more often than you think. And then, if you're lucky enough, you can just create a new version of the code with more details included and reproduce the issue and narrow it down to a few lines of code that can be easily tested. And if you're unlucky, you will have to spend 5 developers a week and just bug hunting, trying to reproduce something, coming up with theories. It's just So the bug fixing is the worst. At least if it's bug fixing on a remote system, live production system with a customer that desperately needs the software to work, but absolutely cannot give you access because of security reasons, which need clearance first, and you have to wait weeks to get a third party to get you clearance to access the... Different topic. Let's not bring work into this. Anyway, this is one way to deal with it, but there's more we can do. There's another keyword we can use when combining exceptions in a try. It's called finally. Now finally is, unlike catch, just the keyword. There's nothing we can do in brackets in here anymore. And finally just means this code gets run whenever this try is done, or this try catch. So we run this code now. The exception happened, and we output the exception, and we write our finally. But we could also have no exception, and it will still output the finally. This is very useful if you absolutely need to make sure that once your code is done, something gets cleaned up, or corrected, or stored, or if there's some code that you absolutely need to happen regardless of whether this worked or not. If this worked, cool, run this code. If this didn't work and you had an exception, deal with it, cool, run this code, no matter what. You can even have this code on your own without the catch. This is independent. This works too. Interesting though, sometimes people don't think about that. While this works right now, there are cases where an exception in here prevents this code from getting run. There are specific circumstances to this where this gets important, just so you know. You can see finally output here, but not in every circumstance you can rely on this being executed. Just so you know. But generally just think of it as, hey, we execute our code and no matter what, run this code afterwards. Let's restore this. Whatever. Let's try this again. Looks better. You guys also seen we don't have the unhandled exception anymore because we've dealt with the exception. Oh, that's too far. Let's try another method on here. Static int sign safe. Let's say this is now calling sign for us. And just returns the value. So what I do in here is save. I call this method sign save instead. So far, not really a big difference except in these stack trays, which is now one level deeper. But still the same exception. Now let's add a try around this part to make sure that if this sign method didn't work, we catch the exception and actually just copy this part out here. We just write out that the exception happened. And in that case, we return 0. Here we are in a situation, in a context where we have the tools to figure out a more specific error handling. Up here, I basically had no way to interfere anymore. I called some low-level code, and if that code had exceptions, well, I don't know how that code works. Maybe it's many, many levels down on the stack, and I just get the notification that something somewhere broke. And so I just did what I could by at least outputting that something broke and trying to not crash the entire process. But here I am in a more specific context. I know I am basically the sign method. My goal is to get the sign for our input. And so our exception handling can actually deal with that situation. We actually have the necessary information to write a failsafe. We can provide a reasonable alternative behavior if this does not work. So if I call this now, we still get this output, but it's the exception in sign safe. Not up here. It's not this exception handling anymore. In fact, I can completely skip this part. Still safe to call. Can actually remove this as well. We get the output for the exception, so we as a programmer can still figure out that, hey, something did happen and maybe I should look into that. Hopefully you've put all this in a log and not just on the console output. But the program was still able to continue. Maybe not in the ideal circumstances. Maybe this now results in part of my screen being just blank. Instead of seeing some data you expected, you just see a blank screen. But the process didn't break and the user has still the ability to input something else, maybe just reload, or do something else, or somehow react at least to it. The earlier you catch the issue, the better. In our case, we caught it right here. And we only go to that method to this method sign through this wrapper method, this helper method signed save, which doesn't throw an exception. We could, however, and let me return to some things. Well, this isn't exactly signed safe anymore. Instead of returning 0, we could do this. We catch the exception that sign threw down here, because the input was 0, and we do output something. But then we just throw the exception back up. We just throw the same exact exception again. We didn't create a new exception, that's important. We didn't create a new exception here, which you should never do unless you have some very, very specific circumstances, like handling with app domain boundaries or COM instance, and you have to make it marshal by ref. And I mean, I had a situation like that where I couldn't throw, but that's extremely unlikely to happen to you. So just never create a new exception, always throw the same exception if you have to throw it further up. And just to be safe, you can just use throw directly. The compiler knows if you don't add anything in here, it knows you're talking about that exception E that you caught. Like if you don't put anything after the throw, that's fine. If you're in a context where we already have caught an exception, it's automatically going to throw that up further. Now when I do this, we get first the output we got from signed safe down here, as expected. And then we caught the exception up here and output that. And then we had our final block, which gave us finally. And this can make sense. For example, if you don't want to deal with it up here, we still know that somewhere that stuff was actually caught and noted. Of course, if I don't deal with it up here now, well, I have an unhandled exception. because even though I handled it down here, I threw it back up again. I caught the exception, I saved everyone, and then I decided to make it someone else's problem further up again. So we just intercepted it briefly to extract some information, which is useful, but then, no, we don't want to deal with that, someone else do that. And because no one else up here actually caught the exception, the entire process crashed with an unhandled exception again. So if you write a big program, it's always a good idea to have one try-catch surrounding your entire content for the main method, the entry point, so that no matter what happens, you have a catch that can catch the exception and write that stuff down somewhere, if nothing else. I mean, if you're just developing in the beginning, that's not necessary, especially if you have a debugger, you will catch every exception anyway to get all the information out. But once you expand a bit and try to have other people run your code, make sure you include something at the top level on the main that can catch any exception and output some information out there. Just write it down in a file. I/O is something we will get to at some point. Now, let's talk about something else we can do. This is a bit specific, but it is very helpful when dealing with exceptions and exception handling and creating your own exceptions at some point. Exceptions are, as mentioned earlier, filled with a lot of useful tidbits that might help you debug your code. And you can add some information yourself. For example, exception has a property called data, which is an array. And what I can do is I can target a specific value, or not, technically it's not an array. You know what, I should probably not talk about that now. That might be getting ahead of ourselves a bit too much. Another time then. We can absolutely though do this. And that way have the actual value that was in there output in here as well. So if something happened in the sign method, we know which input was passed on to sign save. And so we as developers can just create code that uses exactly that value and try to reproduce that bug. Very helpful for debugging. Now let's try to get this back onto save by giving back a default value. Let's actually drop this up here. So I can call this code. It will lock the exception, but it will still give us a value that we can output. But right now, this default value, this 0, in case something broke, is determined by this method signSave. What if I want to do something else in here? What if I want to output a very specific value, or maybe I want to output some string or do something completely different if this did not work, instead of just having some default value? I could check if s equals 0, but that means I have to first know that 0 is the default value if something breaks, and what if 0 is actually a value that might return legitimately? What if I do this? Oh, that's... let's change this. Oops. Like that. So now sign save will call sign, which itself can accept a 0, accept a 2, just fine, it generates a 1. I can accept a -2, which returns a -1. Nick can accept a 0, which just gives us 0. It would just not accept a 1. So, how can we deal with that? We don't want this to throw in exceptions. We don't want any try catch up here. We don't want to deal with the exception handling. But we do want the ability to change the way our code works depending on if this worked or not. We want the exception handling, but without having exceptions. Oh, what if we return more than one value? Right now we're returning just the integer, which we are not sure which integers work and which don't, so we have to assume any integer could be legitimate. The only way to return more data is by having something in here that can output additional data, which we have discussed before already. Like this, for example. We can do it like this. We have an out variable, a boolean, for success. And we start by setting it to true. Actually, let's put that up here. Hotkey combinations, still not getting used to it. So our sign save returns an integer, but also fills this boolean. And we can now decide if success, and just write out, else the output fired. See, it failed. Just use the 0 again, and we just get the 0. So that way we can get the information that it worked or didn't work from this boolean. But we also get the actual information we're interested in from the return value. So we can define our own exception handling this way, sort of. Of course, the exception object in itself would still be more useful. Having an exception at all as information, which we've covered with the boolean, but the details about the exception are not known to us. We only know that it worked or not worked. If we get an exception that we catch, we have the instance of the exception, which can give us additional information, like just a basic method, a message, and a stack trace, how deep did it go, and some other useful stuff. So this isn't always the best way to deal with errors, but it's still a very useful one in many simple cases. As long as you have some way of recording the exceptions further down, it's perfectly fine to just ignore the exceptions themselves up here, the upper levels of your code. Now let's maybe switch this a bit around, because right now I have to store this variable, and I have to store this boolean, and then I have to check the boolean, and then maybe use the variable. This is a lot of writing, and I'm lazy. Since this if can accept the boolean anyway, directly, why not flip this around? Like this. And could give a default value of 0. And override the value with whatever sign returned. And then in this case, we return true because it worked. If we didn't get the exception and we just got a value, well then we return true. But if this exception happened, we catch the exception. In that case, we output the exception and we return false. Oh, that might not have been clear, didn't specifically explain that. Inside this try catch, as soon as the exception happens, the entire rest of the try gets ignored. You might have noticed that earlier when I had both the call to sign and the console output within the try block up here. You never saw the write line for the actual output, because it never was called, because if the exception happens in here in the try block, that meant the computer doesn't know how to proceed. We don't know how to continue with the code. Therefore, the code is never continued, and we just instead go to this alternative code branch. It's like an if code works, continue line by line. Else, if the code doesn't work, just continue here. And then finally, add something from the final block. So, if this works, if there are no exceptions, we will reach this line and will return true. If this does cause an exception, if sign does throw the exception for having the wrong input, we will instead abort this entire block and continue here with the exception. That's why we can return true here, return false, and it will only return true if this did not have an exception, and it will return false only when there was an exception. And value will be 0 by default. We start with assuming value will be 0. So when we return down here, it will have a value of 0 if we didn't fill it any other way. But if it worked, if we were able to process the input, we overwrite the value with another value. And when we return, it will be the actual legitimate intended value. So what did I get wrong? Ah, right, I didn't write this yet. Okay. Might be actually a good learning method. We get a compiler error. What does it tell us? Well, I just see I have compiler error and I already understand what's happening, because it's just a reminder. But let's try to analyze what is meaning here. The best overloaded method match for program signed safe in out in has some invalid arguments. And that's in program.cs, line 7, column 13. Usually these secondary numbers, these columns, aren't too useful. I at least don't trust them, but the line information is good. So line 7, this is where we are. The best overload match for program signed safe. Basically, it's trying to tell me that it sees this as a method it tries to call. It looks for a signed safe, which it sees down here, but this signed safe returns a boolean and accepts an input integer and another integer value declared as an out variable. But what we have here is a signed safe that returns an integer, not a bool, accepts an integer as the first one, but has an out variable with a type bool. So this one has int return out bool, this one has bool return out int. And it's complaining that it cannot find a matching signed safe. It's assuming that this is correct, that this is the method we want to call. It's just not finding any method that's matching. So it's not telling us that, hey, signed safe works differently. It's assuming that there is another signed safe that it just doesn't see right now. So, best overload match. Well, and then it says that we've done wrong. Has done corrected. Has invalid arguments. So it understands that it doesn't see a better match than this. And we've used it wrong. Yeah, I take everything back. I'm just dumb. And then it's, yeah, related to previous error, it's just stating that, hey, it cannot use this out bool for an out int. because I didn't use it right. So what we actually want here is sign save out int value, like this. Actually, let's return this like before, as it was fine. Now we have it. So 0 works fine, -1, well, let's use -2 just to be clear that we don't run the actual value. And +1 works as well. And if we now do 1, we log the exception down here. And we just got a false back, so this if does not use the first block but the second one, and the output failed. And this way of dealing with errors in a not so strict way, extensive way, with exceptions, is pretty common. Like this procedure of just returning a boolean that tells us if it worked or not, and not giving us any more information instead of throwing an entire exception. This is usually used with a try and front. It happens maybe, maybe not. We get a boolean that tells us if it worked. So the try catch is direct exception handling, like actually handling exceptions. And this would be more error handling in general, but we still have the term try pop up. And maybe we don't call it safe anymore, though it is safe, but this is a try sign with the input, and it might give us an output value that's useful, which we can output here, or it will tell us that it just didn't work. We don't know why it didn't work, we just know it didn't work, and we don't think about it anymore. We assume that the code down there has dealt with the exception, if there was an exception at all, on its own. We could of course have it like this as well. Doesn't need to be an exception. Input is 1. That. Okay, let's do it like this. 0. This one. Turn false. Like that. Hotkeys. So we still have a default value of 0, but before even trying the sign method, we know that a 1 would not work, so we just immediately return false. Still works. Yeah. This is the kind of stuff that happens if I'm too fast for myself. So, again. Didn't find a method called signSafe because I renamed it. And I'm used to it being automatically renamed up here. That's the burden you have with advanced IDEs. A lot of stuff gets done for you, but that kind of makes you lose your edge. Because then you forget that, hey, renaming a method is actually something you have to do in every location where you call that method as well. And it's not done automatically for you. Yeah. So anyway, in this case, we don't get any exception output, because there never was an exception. We just decided, no, we return false. So this try something with a boolean return and an out variable that gives us an actual return value does not mean there's any exception handling in there. Doesn't mean there are any actual exceptions we deal with. Just means we try something and maybe it works, maybe it doesn't. It can involve exceptions, it might not. And it can also be a mix of both. That maybe some things are caught without exceptions and then it will actually try to execute that code, and then something else happened that the programmer didn't anticipate, which is why there are catches. So, like this, we still get the exception, can deal with that. And to say that again, this try something that returns a boolean, very common. And we have that in our old friend, the integer class as well. Because instead of just parse, we have also int.TryParse. Let's do string s equals 1 o, not 0, o. TryParse s out int I. And this gives us a boolean. And we can evaluate. It's just because I'm too lazy. Don't try parse. String s equals again 1 o. That. So we're taking our s, our string, with a 1 and an o, not a 0, 1 o, and instead of parse, we call now TryParse. Try to parse this string and put the value that you generate from that into the integer I. And also return a boolean that tells us if you were able to successfully parse or not. It failed, which is understandable. This is not a 0. If I do add a 0, it will just output 10. So the exact same principle we used for our own method down here. And we have that for other types as well. Could, for example, use long.TryParse. We just have to rename this to long as well, but that works. Or byte I stu. Now let's say we use 1000. This is a legitimate integer, but not something that can fit inside a byte. So we have a fail. Let me just see that byte. If I were to just call parse and we force an exception to happen here, we get a different one this time. Earlier was format exception. This time the format was just fine. This is a legitimate integer. That's not the issue, but it's not a value that can fit inside a byte. That's why we get this one. It's an overflow exception. This doesn't match up. We can parse this as an int though. No exception here. And then we can cast this afterwards. That's fine. We just can't directly parse it. So this is fine. This would not be fine. Those are some of the differences between casting and parsing. Different standards for how things work. Parsing is just actual codes that someone wrote with decisions on how to handle certain cases, where they decided, hey, throw an exception if it's not fitting. It has to fit, otherwise we won't allow this parse. But in case of casting, if this is too big for a byte, doesn't matter, just cut off the rest of the values. And it's more language specification. This is code someone wrote. Right. With that said, let's reset all of this. Let's talk about your homework, because it's time for your homework. This is gonna be a bit tricky, so I'm gonna give you a few tips later, but static int parse and this parse should allow us now to parse incoming string and convert that into an integer. That will be your homework, to write this method. And because that is a bit tricky maybe, because something you might not have thought of is possible with strings, I'm giving you a quick demonstration of something. String, just to go back to the start, is an array, a character array. And at least for simple cases like this, each position in that array is exactly one of these characters. This is character 1, character 2, character 3, character 4, which means index 0, index 1, index 2, index 3. And we can access them just like any other array. So this it gives you the first character. This gives you the second character, and so on. That's how you can access specific characters in here. And next one. There's a specific field, well actually it's a property that a string has, which is called length. No? Length. Like this, which will give you the length of the array, the length of this string, how many characters are in here. So this 4, this would give you 1, this would give you 0. So 4 characters. Character at index 1 is the first character and has the character 1 numeral, not the value, the numeral. And that's the last one. I demonstrated that in the last lesson. I can take an integer a like that, and I can assign a character. I could also add something to this character. This is not... Well, let's actually switch that up to 1. This is not value 1 that's inside this integer. This is actually going to be... Where was it? 1... Wait, 0 was 48, so this is 49. This would actually be 49. Well, let's just... Right line... Just to be sure. Just quickly removing this stuff. Yep, that's 49. Alright. So this would be 49. This was 50. This is 48. So that should return like this. That should be all you need. All the rest is just some program you have to write. You don't have to think too hard about exception handlings yet. If you want, you can add exceptions to this. Figure out, hey, this does not work, this is too big, or this is the wrong format. You can include that, that's a bonus. But if that's too much, just assume that this string will be a value that you can convert into an integer. It's a normal integer that's within the bounds of an int, and to make things easy, let's assume that this is only positive. This is not going to be a negative number. Right? Well, everything else, just a bonus if you're feeling up for it. Alright? That's your homework. You can write it wherever you want. You don't have to use this one. Again, I only used this one because it was the first one that was suggested to me that did include the option to change the font size, which is nice for the stream. Otherwise, use whatever you want. If you already have a local dev environment, if you've already done some programming, like actually on your PC yourself, you can use that, of course. And if you want to share your code, use something like Pastebin and send that on Blue Sky. and we can have a look at that on stream on the next lesson. All right, with that, thank you for watching. See you next time.